Welcome back. All right, so we talked about lava flows, typically the gentlest of primary hazards, still cause a lot of property damage. Ashfall can definitely cause a lot of property damage and some deaths. Now let's get into more deadly stuff, volcanic gases being the first of those. So, oops, what happened there? So, volcanic gases are any emitted gases from volcanoes. That includes carbon dioxide and water vapor, which makes up for about 90% of emissions. Water vapor, harmless. Carbon dioxide, deadly. So carbon dioxide gas is odorless, and it's typically heavier than a lot of the other molecules in the air. So if carbon dioxide is coming out of maybe a little fissure at the base of a volcano, it might not just go into the atmosphere all of a sudden. If it comes out a lot, it's heavy and might sit down kind of in a low-lying area, like a little valley or like a little lake area, before it kind of makes its way, kind of mixes into the atmosphere. So it depends on the weather and temperature too a little bit. A little too complicated for what we need to understand, but imagine there's a little fissure where a little crack, a little break where carbon dioxide is coming out of maybe the base of a volcano, even maybe far away from it. If it accumulates in any certain amount, it's heavier than the surrounding atmosphere and the air, so it displaces some oxygen. So oxygen is lighter, so it kind of gets pushed out of the way. And if you're in this area, well, there's no oxygen for you to breathe. All you're doing is breathing carbon dioxide, which will kill you because there's no oxygen. So you can suffocate. So carbon dioxide is a very real, dangerous, poisonous volcanic gas, as well as sulfur dioxide. Not necessarily kind of the same way it's a hazard, but what sulfur dioxide can do is kind of mix with the air and atmosphere, and if it kind of mixes with moisture as well, can create acid rain. Because sulfur dioxide mixed with water and air creates sulfuric acid, very weak sulfuric acid. So I'm not talking like acid rain that you see on a movie where it rains on some people's skin and their skin starts to bubble. No. It's very weakly acidic, so you wouldn't even notice it, but over time, if you're in an area that is volcanic, it produces a lot of sulfur dioxide and gets into the air. The rain is acid rain, and it can slowly eat away at buildings, at statues, at foundations over time. It can eat away at these things. It's not that it's going to burn your skin. It's not good, but it ain't going to burn your skin. So again, imagine, for instance, carbon dioxide. I know this says sulfur dioxide, but coming out of it might not even be erupting fully. It might just be pumping out gas. And these things can affect people, and more so on the death side with carbon dioxide, more so on the structural side for sulfur dioxide. An unfortunate example of CO2 carbon dioxide release was Lake Nyos in Cameroon. So not necessarily a volcano in the area, but magmatic activity underneath. And so a little fissure erupted, some carbon dioxide was released into the area, I believe at like nighttime. And so while people were sleeping or just relaxing, so you have all this carbon dioxide that's now in this area displacing the oxygen. Over 1,700 people suffocated, over 3,000 livestock. You can see a bunch of cows here, all died. Imagine everything just dying, just right in their sleep, just dying, just dead, never to be woken up again. And that's because carbon dioxide, leaked out of, some magmatic activity, suffocating everyone. Good times. Speaking of good times, pyroclastic flows. These are the most lethal hazard of volcanic eruptions. All of these things, these are caused by the eruption, and these things can cause death and destruction. But pyroclastic flows, by far, number one hazard, primary hazard of volcanic eruptions. They're a hot cloud of ash, rock, poisonous gas, superheated, racing down a mountain at about 250 miles an hour. So when a volcano erupts in a Palaeon-style eruption, you may get one of these. So some stuff is kind of erupted up into the atmosphere, but some of that stuff kind of then comes back down. Again, a mix of hot ash, rocks, poisonous gas. It's coming from a volcano, so it's superheated, moving 250 miles an hour. Anything that is in the way of that is gone. Anything. It will suffocate you, it will cut you, it will crush you, it will burn you, it will poison you. Anything in the way, just done. These are also known as ash flows or hot avalanches or glowing clouds. At night, there's just this red cloud racing down the side of the mountain. And they're absolutely catastrophic if they hit a populated area. And again, the most lethal primary hazard of volcanic eruptions. They're responsible for more deaths than any other primary hazard. So here's a little image of a pyroclastic flow. Here's an actual picture of what that might look like in a Palaean style eruption. So you do get some stuff erupting up into the atmosphere, but again, you get this hot burning cloud of ash, rock, dust, poisonous gas, superheated, moving 250 miles an hour. Anything in their way, not surviving. And that's kind of what happened in the city of Pompeii at the base of Mount Vesuvius. When Mount Vesuvius erupted a couple thousand years ago, this was during ancient Roman times, a pyroclastic flow came in, just buried the city of Pompeii. It happened at night, so when this pyroclastic flow raced through, it buried most people right where they were laying. So these images you see are kind of how the last images of Earth what they were like on the last images of Earth, or last moments on Earth. So what happened, this actually town, since it was buried by a pyroclastic flow, was lost to antiquity for a couple thousand years. And it wasn't until like the 18 or 1900s that it was rediscovered. And as they're digging out the town, they would notice that all of a sudden they find these cavities, these empty holes in this kind of ash as they're digging out. And they noticed that there were bones in these cavities. And once they would start to find these cavities, instead of just kind of ripping them up, they'd make a little hole, put some plaster in there or concrete, and dig around it. And then they noticed that these cast formed shapes of people, indicating that this was the last moments on Earth. This is what they looked like. This is what they were doing when that pyroclastic flow raced in. So there's adults, there's kids, there's animals. They took some of these on tour, these casts on tour, and there were some at the Arizona Science Center a number of years back. Very striking. So those are all primary hazards. So those are all things that cause death or destruction that coming from the volcano itself, coming from the eruption itself. But then there's also secondary hazards. The stuff coming from the volcano caused something else that caused my house to be destroyed, or that killed so-and-so. Fires, earthquakes, lahars, tsunamis, and then climate change. Fires, kind of to the point, it's not the lava that burned down my house, but the lava created a wildfire, and the wildfire burnt down my home. That is a common secondary hazard. Earthquakes, they usually accompany or sometimes even precede a volcanic activity, but it wasn't the eruptive material itself, so but the eruption occurred, which then caused an earthquake, which then caused my garage to fall down and destroy my car. So it wasn't the volcano products itself, as the volcano caused something else. Lahars, excuse me, we'll come across this term again when we get to our unit on mass wasting. Lahars, as some examples, debris flows, mud flows, or landslides, are when loose volcanic material, ash or rocks, becomes somehow saturated with water, becomes unstable, and then moves down the volcano. So for instance, a debris flow, as an example, imagine there's a mountain peak, it's a volcano, and there's ice and glaciers on top. It erupts, there's a lot of hot heat coming out of there, melts that glacier and ice, so that glacier and ice turns to water, rushes down the slopes of the volcano, picking up rocks, sediment, picking up boulders, picking up trees, anything it can, and just rushes down the mountains, down through river valleys below. That's a debris flow. Mud flow is kind of the same thing, but not with not so much big stuff in it. No big boulders, no big trees, kind of smaller material. Landslides, okay, let's say a volcano erupts. Maybe it erupts this way, But because it erupts, it later causes a landslide on the other side, let's say. And the volcanic eruption didn't destroy my home, but when the volcano erupted, it then caused a landslide, and the landslide destroyed my home. Secondary hazards. And these mud flows can flow for 50 to 100 miles. So this town wasn't even necessarily close to, volcanic activity. But if you have volcanic activity, and it could be 50 miles way off in the distance, you can't even see the volcano. It's that far away. But it erupts, melts some water. All that water comes rushing down, picks up a lot of material with it. In this case, just a lot of dirt. And then a mud flow flowed into this area. And you can see covering, a good portion of houses and buildings. These are actually two-story buildings. You can see the tops of single-story houses barely peeking above. But some of these two-story window buildings, the second story is above. Mount Rainier in Washington State, Mount Rainier National Park, yes, the one I climbed, has exhibited through history, the past 1,000 years, a number of lahars. So a lot of ice and snow on top of Mount Rainier. So when it erupts, it doesn't erupt explosively. Mount Rainier, it's just different volcanoes are all different. It is a stratovolcano, which typically do explode, but Mount Rainier is a little bit different. It really gives out more heat than just explosion. So it tends to release heat in small amounts of heat, really releasing the pressure over time instead of just building up in one big explosion. But in any case, over the past 1,000 years, they've tracked the number of lahars that have flowed off Mount Rainier. So it'll release heat, melt the snow and glaciers that are ever present on top of Mount Rainier, turning it to water. That water rushes down the side, picks up material, and these lahars can flow for upwards of 50 plus miles all the way over to Tacoma. Seattle is just not too far north of where this map ends. We know that volcanoes can be triggers for tsunamis, whether those volcanoes are above the ocean surface or below. So tsunamis are a secondary hazard of volcanic eruptions. And then climate change. So if a large eruption occurs, if you put a lot of ash up into the atmosphere, it's going to block out the sunlight, cause global cooling. Now, there are some people that say, oh, that's great because we have global warming, so let's get a big volcanic eruption so it'll cool everything down. No. Well, yeah, it'll do that, but when you block out the sun, you hurt the things that depend on the sun. For instance, plants. Plants need sunlight to help photosynthesis, to create food. No sun, no plants. No plants, then no things that eat the plants survive. No thing that eat the plants survive, then most humans will die because you're focused on meat eating. So yeah, not a good idea? Maybe? I don't know. Just me. So we're going to pause here. When we come back, we'll talk about how volcanoes impact society greatly. Spoiler alert. But before we do, let's take that super secret code, all those numbers that I've given you, all right? All those numbers that I've given you so far, you have them in order, flip them backwards. All right? All those numbers in order, flip them backwards. All right? Flip them around backwards so they're going the opposite direction. See if that helps out with the super secret code. Let's pause here, and I'll see you when we come back for section 5.